Thanks for coming to the last session and our last session of the Dev Summit. This session is about AR, VR, MR, and ArcGIS, collectively referred to as XR. With me today is Rex Hansen, who's the product manager for Runtime. Adrian Moreau, who is the lead software dev for AR, VR, and Runtime. I'm Eric Whitner. I'm a product manager for Esri. I'm focused on CityEngine, urban, and urban planning in general. I want to start by going through a little overview of the terms and the ideas in XR, just so we have some clarity. Touch on some of the offerings that we kind of deliver out of the box, and then turn it over to Rex and Adrian to talk about the runtime and building AR, VR, and MR on top of our runtime. So, virtual reality, probably most of you are already deeply familiar with it. It's being there. It's being immersed in a place that you're not actually in. So it's a great way to actually put people into either something that doesn't really exist, like a game, or see something that doesn't exist yet, like a proposed design, or see something that they couldn't normally physically see, like stripping away walls and looking behind them in a virtual location if they're doing some virtual reconnaissance. Augmented reality is overlaying on top of your vision of the world additional information, so you're interacting with the outside world. And here we have an example with Adrian showing some augmented reality where you're overlaying information on top of your camera through your phone, and it's giving you directional information to help you navigate through a space. And this is really exciting for people, especially in the facilities management or in the emergency response world, where they can overlay information that they have that's spatially managed on top of a vision of the real world to help guide decision making. So here you can kind of see him walk down the hallway, and it's using the routing to indicate where he needs to go in order to get to his boss's office to report, or et cetera. Another place this is probably, or is very desired, is in campuses, being able to find your way around. The mixed reality is a mixed presence, so you're kind of blending these two things together. You're taking a view of the world, and you're inserting into it this virtual presence of something that's going to live in there. So something like Microsoft Hololens or Magic Leap. So this is an example from the city of Zurich, where they're actually using it to overlay representations of what the development's going to look like in the future, and then allow people to walk around their neighborhood and see those proposed developments interactively in 3D to understand the kind of size and mass of it. So inside ArcGIS, there's multiple ways to build these different kinds of experiences, but the core, of course, is always the spatial data. And a lot of the times we'll pass it through CityEngine and hand it off to something. We might hand it off to something like ArcGIS 360 VR, which is a lightweight mobile app. We might use CityEngine and go through into the premium VR experience that we've built for HTC Vive for urban planning. Or you might just take the GIS information out and bring it into Unity and Unreal and build solutions inside those gaming engines. The other way is you could consume that GIS data directly using the runtime and then build an AR app or even a VR app or an MR app on top of that. So there's a couple concerns when you're talking about XR. One is positional tracking, and there's different approaches to positional tracking depending on which of these implementations we're talking about. If you're in VR, one way that you might track information is outside in. So you're wearing the goggles, and you have things that are watching you, and they're tracking your position, and they're looking at where you're looking, and doing the head tracking. They're looking at where your hands are, and understanding what you're touching, right? But that requires kind of a set of markers or a set of devices that are looking in at you. The other way is outside in. So the device that you're wearing, like this, right, would have a set of cameras or would be a reference to a location that you're looking at, and then that gives its position and understanding of movement. The challenge there being when it's outside in, it's harder to track things like your hands because your hands are in front of you, so then those devices have to have more kind of controls associated with them. There's a distinction when you're talking about virtual reality between the high end and the low end, the premium VR and the mobile VR. The premium VR is mostly outside in tracking. There's Pascal, he's hiding in the back. The premium VR is mostly outside in tracking, so it gives you that precise control. It's better for giving you that 6 degrees of freedom when you're moving around and get smooth feedback. But those systems are generally pretty expensive and they require some knowledge on how to set up. They have great graphics, but they're attached by a cable, so you're tethered for all intents and purposes. But they provide the richest experience. On the other end is the mobile VR. Mostly the tracking there is outside in, so they have their own gyro or their, inside out, so they have their own gyro, their own camera reference. A lot of times they limit the degrees of freedom to 3 degrees of freedom. And if you want to go to 6, a lot of times they make you enhance it with like a controller so you can slide backwards and forwards, but they're not doing that with the device itself. The advantage is that they're pretty cheap. You can get a Oculus Go for like $200. You can throw your Samsung into a Gear VR for $100. They're pretty simple to set up, but you're limited to the graphics card that's on the device, so they can't do nearly as much or look nearly as stunning. When you start talking about mixed reality, there's a whole different set of kind of alternatives for how you're going to do positional tracking. So you can do inside out and then use motion tracking, but you need an initial position to understand that. So in this example, Jack's looking at a virtual image of a development again in Zurich, but he had to look down at that location reference so that the mixed reality system could project it down on the floor, and then he could walk around it and look at it from different sides and get close and interact with it. When you're talking about augmented reality, then it really comes down to global positioning traction or other kind of location-based tracking. And if you've ever played with something like Pokemon Go, right, if you're relying just on the GPS, that can get kind of coarse in terms of its position, so you're going to have some jumping and some issues. That gets better when you refine it with tower triangulation. It gets better when you include Wi-Fi. If you can afford to install beacons, right, you can get even better improved precision, get sub 1 meter, or you can also use RFID. And the quality of the experience is going to be related to the ability to track your position. The better you can track your position, the better experience you're going to have in terms of being able to overlay on things. The user interfaces for interacting in environments kind of are really important and continue to evolve. One common practice is to build table scale or tabletop user experiences. It's very common in MR, VR, and AR. The idea is that you put people around a virtual table, then they can kind of collaboratively interact with that table, and that doesn't mean you're constrained in terms of what you show on it. You can actually put more data in it or move, and we'll show an example of that. But the nice thing is it gives people kind of a common thing to understand when they're intuitively interacting with this view. The other thing is because all the motion is related to their body and they're all kind of around this table, they don't get any motion sickness. And so this may look a little bit weird, but here's a group of guys sitting around a table playing a game and all interacting kind of at that scale. And it's pretty intuitive or more intuitive. Well, we took that concept and we wanted to capture it and make it more broadly available. So we built this premium VR app on top of Unreal for urban planning that connects with CityEngine. It's supported through the Unreal export from CityEngine. The idea is you can take a proposed design in your city, you throw it onto this tabletop experience, you have multiple users who are looking at this table. They can interact with it. They can use the table to rotate, pan, zoom around the city to look at the design from different angles, right? And then they can actually get physically closer to it as a way to get closer as well. It has controls that allows you to switch through different scenarios. So you can look at different kind of alternatives and see which of the proposed designs is the best one. You can also change environmental factors like the time of day and the sun to see what the shadow impacts of that are going to be. And because it's in Unreal, you can also include other atmospheric effects, clouds, rain, etc. And then you can drop you and the people you're collaborating with down onto the street corner and look at the proposed design and get that kind of human view, which is the most useful view for understanding the design with your collaborators. The input environment is continuing to evolve. So this is the HoloLens 2, and it's got kind of a totally, if you remember the old HoloLens, it had the kind of like pinch to interact workflow, and now you can see they're actually capturing the full hand and kind of exploring what you can actually touch and change. And the interesting thing here is they're investing a lot of time in trying to understand how people are going to interact with items and things within these environments. What do buttons look like? What do menus look like? What is the kind of foundational interactive interface for mixed reality or virtual reality that's going to be used in the future? And we're all used to very common patterns when we're working with our computer screens, and they're actually starting to build some of those common patterns inside these VR, MR, and AR environments. So very interesting there. So yeah, again, just to touch on the core of what we're talking about in authoring, right? It's about GIS data either through CityEngine into one of our pre-authored VR experiences or into a gaming engine that you can use to build your own experience, or using the runtime as a way to build XR experiences. So I want to talk about two little apps that we have built for VR and AR. One is ArcGIS 360 VR, which is a mobile-focused VR experience. It's actually was designed initially to be delivered on the Samsung Gear VR. We've added Oculus Go support. The idea was to make building a VR experience as easy as possible for CityEngine users, like a one-click export. You get an item, you push it online, and you consume it in an app, and you have a virtual reality experience. The use cases that we were after is we had a lot of customers in the urban planning space that wanted a simple VR demo that they could give to the public, where the public could look at proposed designs and scenarios and compare them visually. You could put them in the perspective of the street, or you could actually, if it was a specific stakeholder, you could put them into their living room, have them look out their window and see this proposed design and decide which one would have the best impact. And we'd been doing this kind of work in the past using Unity and a little bit in Unreal, but the challenge was it took too much time to basically get it out. They wanted to be able to say, okay, I've got this stakeholder at this location, how do I build this? So it was this quick immersion experience that they could produce very rapidly out of CityEngine. So it's a new ESRI format, 3VR. Actually, under the hood, it's really simple. It's just a bunch of spherical imagery that we've rendered out of CityEngine multiple times. One image per different scenario, and then collections of those images for different locations. And then for each image, we store all the other locations as visual bookmarks so that you can switch between them by looking at a blue visual bookmark, clicking on it, and boom, you jump to it. And then you have that 3 degrees of freedom where you can look around in any direction and then flip between alternatives. So it's authored from CityEngine. We've had plans to author it from other applications as well in the future. And it's viewed in this VR application for Samsung Galaxy. And I actually have an example of it if you're interested in taking a look and trying it out at the end of the session. Happy to show it to you. But under the hood, it's just spherical imagery wrapped in JSON that you consume as an item type on ArcGIS Online. So you're actually creating it, uploading it as an item type online, and then inside the application, you log into your ArcGIS Online account. You can search public VR files that are available. You can search your groups. It's managed just like any other item in ArcGIS Online. You select one, it's downloaded to your app, it's stored there locally, and then you can open it anytime, even when you take it offline. So let's talk a little bit how they're made. So this is Esri CityEngine. What I've got here is a representation of our Zurich R&D center. I've got a set of bookmarks that show me different locations within the R&D center. Those bookmarks are going to be where I'm going to be creating my locations inside this VR experience. I've got this export manager to 360 VR. I can select which bookmarks I'm going to create. I can select which scenarios are going to be included. I export it, upload it to ArcGIS Online, and this is just a lightweight web viewer that we made for looking at these kinds of files to give you an impression of what you would see if you had the actual goggles on. But I click on a location, I zoom to that location, and then I can look around and see things. So right now, it's an Esri Labs project. So if you're interested in giving it a try, you can log in to our early adopter community, sign up for ArcGIS 360 VR as a labs project and give it a try. Right now, we've just done a release for 2019.1 with some minor bug fixes and Oculus Go support. We're doing some additional bug fixes for 2019.0, which will be out in May. It's still not a publicly available app, so you still need the key to access it through the Esri Labs webpage in order to install it. And our plan is, as WebXR performance improves over time, we want to make a web-based app version of this, which will just be hosted on ArcGIS Online, so you won't need to install anything to consume it. I also did want to just briefly on Audio, which is another Esri Labs exploration project in augmented reality. It's also in maintenance mode, and we've gotten some good feedback from customers who've used it, and there's been a lot of interest in kind of expanding its capabilities in terms of what kind of data it can represent. So there's kind of some next generation audio work going on. I'm going to leave it to Adrian to talk a little bit more about that in terms of AR story maps and the runtime. So with that, I'm going to turn it over to Rex to talk a little bit more about the runtime.
Great. Awesome. Thanks, Eric. You guys hear me in the back okay? It's good? Okay. Great. So now we're going to talk a little bit about extended reality and ArcGIS Runtime, but really this is a concept that we'd like to apply to just developers in general. So think about, as developers, what you want to be able to take advantage of in the context of extended reality. So first I want to start with just a single slide here that goes over really the full spectrum of extended reality experiences. This really hits on a number of the things that Eric talked about earlier. And really what we're talking about here is being able to take your physical reality and be able to blend that in some capacity with a digital reality, right? A representation of a digital representation of reality. And so thinking about how you transition along this experience where your current physical reality, you have presence, you exist in a specific location, a specific time, and being able to enhance that with digital content so that your location still matters and that basically your interaction with that digital content is honored. As you begin to get more immersive into your digital reality, basically you're teleported to another experience. And so think about these different parts of this spectrum. As you start within the augmented reality experience and you start to supplement your physical reality with virtual content, you still want to honor your location. Of course, on the other end, you've actually teleported yourself to another location. You're actually experiencing another digital reality. And you're moving, possibly want to be able to move or manipulate that reality as you would in your physical space. What we're looking at here is trying to find a perfect blend, right, of both immersiveness and presence. And that perfect blend at the mixed reality middle here, sort of this sweet spot in the green, is really something that we look at being able to provide whether you're looking to go with an AR or VR experience. And so there's a set of devices that really match these capabilities right now. A lot of times it depends on use cases around devices as well as an experience that device can provide. If we look on the outer ends of this spectrum, what we see here is that as we start to transcend or as we start to enter, as we start to move to the middle, we're looking at using devices that you have in your pocket today, things you're already using today in another capacity, and enhancing those devices in a way that you can take advantage of an augmented reality or a virtual reality experience. Take your mobile phone. Right, so for example, you can use your mobile phone, flat screen, camera feed on your mobile phone. Working with that camera feed as a representation of your physical reality, supplementing digital content on top of that, and having it respect your movements in location and in space and time. On the opposite end, on the virtual reality side, being able to take that mobile phone, drop it into a headset, actually in like a cardboard, and be able to experience another location. Of course, at that stage, you're looking at degrees of freedom, and so being able to interact in that virtual world more immersively is something that we'd expect to achieve as we move towards this sort of middle mixed reality section. And this really depends on the devices that you're working with and the capabilities of those devices. And so once we get to the middle of this section, we're looking for a holographic experience, things that feel more really immersive, but still honor your presence. You're looking at holographic devices like HoloLenses or Magic Leap. So you're basically supplementing your physical reality with a digital view that provides a true sort of stereoscopic experience, objects that you can interact with that occupy volume and space. But then also on the other side, are working with really an immersive device like an HTC Vive or a Rift, something that provides those 6 degrees of freedom where you're feeling more natural in a virtual environment. And as you move and manipulate that environment, it feels natural. And so trying to find that sweet spot in both of these experiences is key. One thing that is common, though, in trying to find that is most of the customers that we've worked with over the past, I think we've been sort of working in this area for almost 3 years now. A lot of the customers that we work with and the developer side of the house are working in a variety of different industries, but all of them have their own authoritative geospatial content. Some of it's live online, some of it's local. They want to be able to utilize that in a better way, in a variety of these different perspectives and experiences across the spectrum. But there's a couple of things that come up, and these are some critical needs for initial usability. In the virtual reality realm, you need high fidelity. You need adequate performance so that the individual that's experiencing that virtual reality doesn't get sick. They don't have a bad experience, right? So you need that to be immersive. You need the system itself on which it's running to be performant so that you can provide a good immersive experience. Augmented reality needs positional accuracy. Eric talked a little bit about the different techniques here for getting a better position and being able to accommodate for that in a more pervasive way. There's a number of different techniques to do that, and a lot of times they supplement one another. But being able to make sure that you have the devices and the resources you need to get better positional accuracy is important when you need to be able to accurately represent digital content over a physical reality. In all of these, they need to be cost effective. Are you going to buy your 300 strong team of field workers HoloLens 2 devices for $3,500 a pop? Or are you going to use that tablet that you've already bought them, for maybe $500 or $700 that they already have in the field, and you want to be able to supplement that workflow, right? So it needs to be cost effective. You need to be able to deliver this experience in a way that can maximize the return on investment here too. So that's obviously a concern here too. What are we seeing in just general market trends? So I pulled some stats here, and we see there's a lot of different places to get these stats, but one thing I wanted to get here was really an idea of general market trends within VR and AR, and where do we see these going? This is from a Digit What it's showing here is the positioning between mobile AR, premium AR, mobile VR, and premium VR experiences over time. What we can see here over the next couple of years going into 2021 is that obviously the forecast is that mobile AR, and this assumes that people are upgrading devices to the latest device so it has the latest capabilities and sensors available, is going to be a major growth area. And I think there's a major opportunity there, obviously when we're working with geographic information, to take advantage of this capability. So this is just a general market trend we see. What's interesting is that a lot of the industries, it's fairly pervasive. It's not just one industry looking at this. We can see folks within natural resources, utilities, healthcare, transportation. It's pretty equally spread. Now this is based on enterprises that are interested in this area and where they're investing their time and their money to be able to build out a solution that really enhances their existing workflows. So fairly evenly spread, so a fairly pervasive coverage, which is good to see at this stage. That's market trends in general. Let's take a look at extended reality market trends in GIS. What's the feedback that we're getting over the past couple of years on where folks want to be able to take advantage of this? There's a number of different industries and applications where we see this, and obviously in the AR mixed reality experience, field operations are key. Being able to take that digital content, that authoritative geospatial content you have, into the field so that you can make better decisions is critical. So folks like utility companies or mining companies, folks that work in the field and need to be able to accurately locate themselves and resources around them, assets, and be able to manipulate those assets in some capacity has been critical at this point. Another one is planning. So being able to get a perspective idea while in the field of what a new structure or a change to a structure looks like. What's critical here, of course, is being able to accommodate for existing devices that are available. So being able to use a handheld device, phone or tablet, take that into the field. These simple enhancements can really maximize your return on investment. We've seen some examples of that already. It's not really changing your workflow completely, it's merely enhancing that workflow. Of course, the head-mounted experiences are something that folks are looking at, being able to provide a more, really a more immersive experience for augmented reality solutions. And so these full-scale experiences when you're in the field and you want to be able to move and manipulate and see structures that are, let's say, beneath a surface or behind a wall, being able to have that use both eyes, stereoscopic or that parallax impact or parallax experience allows for a more immersive experience. But you do need really a true sort of premium AR experience for that, a premium headset to be able to drive that. A lot of times that's expensive, so it can be cost prohibitive, but there are still some needs there that we find that some organizations are willing to spend the time and the money to be able to build that today. Of course, over time we will see some of this, the price of this technology go down. We'll be able to make this more pervasive, which is great. In the VR sense, we're looking at a lot of situations right now where folks are looking at education, and this includes not just academic, but also in the field. So being able to, you're a park service, you want to provide maybe folks before they visit, kind of a virtual experience before they show up. You can allow them to navigate through the park and see things, or if they're not able to attend or not able to be there, you want to provide them with an experience that they can enjoy. Planning is another one. You want to provide a way for a set of constituents to be able to view a plan before it's done, to provide them with some insights into what to expect. Training is key here too. This is interesting. Being able to provide a workforce, this has been common in some of security or law enforcement situations where they want to provide them with a sort of an idea or a situation before they go on site, to be able to give them a heads up as to what they're to expect before they get there, so that they have they're able to adjust or they're able to figure out exactly what they need to do when they're on site, actually. So it's a sort of a precursor to an existing situation that needs to be, that will occur. Of course, mobile devices are key here, so being able to reuse, again, easy, cheap to distribute. Granted, some of the performance on some of these mobile devices can be challenging. Desktop devices are obviously, they have the power to be able to drive these premium VR experiences. They can be costly, but you're going to get this full sort of immersive experience with the VR driven by a desktop. So it's things like HTC Vive or Oculus Rift that'll provide you with the best VR experience possible if that's something that's necessary. What we are seeing now actually in the mobile VR space is that some of the chip providers are actually generating or creating mobile devices that they're specifically designed to power some of these premium 6 degrees of freedom experiences, and so we'll begin to see that line kind of blur as we move forward. Again, devices that are specifically designed for VR, not something that you have in your pocket and you're just using it in that context, right? So there's a lot of innovation happening in a number of these areas with respect to devices. Great, so that's some of the market trends we see in GIS over the last couple of years. What have we done thus far in the developer realm to be able to accommodate for some of this? Well, about a year and a half ago, we spun up a private beta program using ArcGIS Runtime. And we initially targeted really the full spectrum to see what we could handle, what we could do, what we could accomplish. And so that went out with a number of different SDKs, .NET, iOS, and Android. And obviously with Runtime, we already support 3D capabilities. And so it was more about enhancing those 3D capabilities to provide a mechanism to access all of the data sources and capabilities that are available to Runtime, but really supplement that with a synchronized camera feed, right? So that we could organize virtual and physical space in the same place. So, and in addition, because we're working with Runtime and it's a native SDK, we can take advantage of all the sensors we need to get better positional or relative accuracy. And so really building on top of that capability. So right now we're still in beta. We have iOS, Android, and .NET SDKs available. What we've determined though over that time is that we don't have a rendering pipeline that's optimized for VR and Runtime, right? There is work going on to optimize that going forward, but it's not optimized for it today. And so while that will take some time to be able to build that out, we do have a rendering pipeline that will support augmented reality on mobile devices today. Why is that critical? Well, why is that necessary? Why did we choose to go with augmented reality on mobile devices? Because we really need that positional accuracy that comes with some of the AR capabilities like ARKit and ARCore on iOS and Android, plus those are the devices that folks are taking in the field. So we're really targeting that sort of field experience going forward. And so what we're looking to do right now is being able to build out an augmented reality solution for mobile platforms only, so any runtime SDK that supports mobile. That means .NET, iOS, Android, and Qt. Of course, we're targeting devices that have or can support ARKit and AR Core, and that'll be our goal actually coming out later this year. And so we're looking at update 6 for runtime is coming out in Q3 this year. In that time frame, we're looking to deliver this for use in production. And so we'll have a foundation that'll support AR on mobile. At that time, we'll be delivering a toolkit. Our plan is to deliver a toolkit component that will enable you to view all the source code that's used behind the scenes to power that experience. You as a developer can take advantage of that and enhance it with other inputs to get better positional accuracy, define the field of view, other things like that you need to be able to adjust in the context of an augmented reality experience. Again, this will not be designed for VR, mobile VR. It's not designed for mixed reality either. We had some ideas that maybe we could be able to target things like HoloLens with a UWP application, but in reality, that experience is less than ideal because we need to be able to have that immersive experience that allows for things like occlusion, and we weren't going to be able to build that within runtime. That's why we decided to go with a mobile-first AR experience. If you're interested in joining the beta, there's an email here, ArcGIS Runtime AR VR Beta at esri.com. Feel free to send off an email and request access. If you've requested it this week, I'm sorry, we've been kind of backed up a little bit. So if you've requested it, haven't got a response yet, you will get a response. We're going to get back to this. It's been a pretty busy week. So you guys will get in shortly. With that in mind, I just want to show some examples. We've got a couple of screenshots on the side here, but just want to show a couple of examples here. We saw this a little bit earlier in Eric's presentation, but this is kind of the end of that video. This is Adrian in the hallway at Esri headquarters back in Redlands. He's typing in a name of his boss's boss, actually, and trying to find out how to get to his office. This would be Sud, I believe. Yeah, exactly. Either it's for a raise or you're in trouble. So anyway, he's trying to figure out how to get there. So he's typed in his name. He's using his phone here. He's solved for a route that respects three dimensions. And so in this case, that route through the building, represented at full scale, is being displayed as arrows to show him which direction to go. So now he's going to walk out the door, and it's going to take him down the stairs. A little assistance there, which is nice. It'll take him down the stairs, and it'll get him to the proper location. What's nice here is that we're taking advantage of some of the sophistication that's built into runtime, right? So the ability to find a location, solve for a route, honor basically the three dimensions of the third dimension of that route, and then be able to take that information and drape it on top of a surface here that matches up or is synchronized with the camera feed from the device. Right, so being able to build out a solution like that is great. So a very common use case, being able to navigate and use really a heads-up display within the device itself. Here's another example here from some work that was done with our Esri UK office, working with RNLI. They're a nonprofit organization that we're looking for a way to reach out to their constituents to be able to provide them with a way to report incidents that occur off the coastline of the UK. And what they want to be able to do is provide something that goes to a mobile phone, something that someone already has, be able to tap on a location and then send that information back to the RNLI. The RNLI can actually receive that info based upon the information that was provided and dispatch any emergency services. Right, so an easy way to get something into the field that the general consumer can use and understand and provide some feedback that's useful. Here's some examples here of folks that have used ArcGIS Runtime, the beta, to build out solutions for utilities. So we have a couple of water and gas utilities. I think this is from our Esri France distributor working with a local company there. And then our Esri China distributor is working with a local municipality, in this case, looking at water structure utilities. What they've done here is they've taken those structures, they've snapped them to the ground because, as I mentioned, we don't have a parallax effect. It's difficult when you're showing accurate depth to have that show exactly where that pipe or that asset intersects the ground. And so what they've done here is they've brought it to the ground, they've draped it on the ground so you know where that pipe, where that manhole, where that asset intersects with the surface. So what you can see here is we've got a set of lines, we've got some models that represent features as well as some labels, billboarded labels. Again, this is using Runtime's built-in 3D capabilities to render, just leveraging some of the AR capabilities that we have in the beta to be able to overlay that content, respect the position, and be able to basically view your physical world through the camera feed, all in one space. All right, here we go. So this is, okay, this is last year at the Dev Summit, we showed off an AR collaboration experience. This is using ArcGIS Runtime. If you guys were at the plenary last year, you saw this. This is Adrian on stage, showing off really a tabletop experience using ArcGIS Runtime. He's showing basically downtown San Diego, 3D objects. These are buildings, textured buildings of downtown San Diego. And the key here is that instead of using your finger to pinch and zoom or using a mouse or something like that to do that, he's using a natural movement. He's walking through this basically virtual content. These 3D buildings. If he wants to look down, he can move the phone. If he wants to get lower, he moves lower. If he wants to get higher, he moves higher. And he rotates his body in a natural way to interact with what could conceivably be a physical model that's rendered virtually on a device. So it's really kind of a window into this other world that's available on the, on the floor in front of him. There's going to be a gratuitous, there's a prop that's me actually coming out here shortly. I'm going to wander through this sort of digital garden of buildings. And I'm going to have a device, and I'm going to start looking at a few other things here. I'm going to start looking at those buildings. And so Adrian maybe wants to see what I'm looking at, what I'm interested in. And so what he'll do is he'll enable the ability to communicate between these two devices. This is just using standard messaging between these two iOS devices. He's going to overlay an avatar on top of that model, so you can see me kind of wandering around there, right, as a white individual, I guess a white model. Is that right? And then he'll flip on a switch, and then he can see the view shed for what I can see from my perspective, but from his angle, his perspective. So things that are in green are things that I can see. Things that are in red are things I can't see, but they're within my view. And then things that aren't lit are things that are not within my view. And so as I move around, of course, he gets a good perspective here on what I can and can't see, maybe provide me some information, maybe get some details about what I'm interested in, what I'm looking at. All right, so a very interesting mechanism here for providing working with a tabletop or maybe even a floor top experience here, but getting some information and collaborating around what folks are looking at, what they're using. And with that, I'm going to hand it off to the man himself, Adrian, to run through some demos and show us a little bit more about the beta program. Adrian.
Thank you, Rex. So once you send us an email at the email alias that Rex just mentioned in his slides, then you get the opportunity to log into our early adopter website, and that's what it looks like. You can see that right now we have almost 300 users. I think we're definitely going to pass that bar at the end of this conference, considering that we have about 20 emails waiting for your reply, Rex. Yeah. And then you can see that we're already on our third beta on the left of the page there, and you can download the bits for iOS, Android, or Xamarin if you want to target Android and iOS using the .NET. So how does it look like when you download the bits? So you have basically the package, which is basically the iOS DLLs. You can see that. Or for Android, you have the same thing. And then you have a guide documentation. This is basically a small guide and a small API ref for only the AR API, AR-specific APIs that are part of that beta. But it's built on top of update 4 of the ArcGIS Runtime. So you have access to all the API that the runtime at update 4 has. So you can just go to developer.arcgis.com and learn how to develop a runtime application in 3D. And in addition, this guide will just give you the few extra bits that are necessary to enable a mobile AR experience. You also come with a really simple demo. It's really to help you get your first step inside in AR. So I have the source code of the demo that is part of the beta downloaded here. And if you're a runtime developer, this code will look really familiar. But if you're not, it's really, really simple. As Rex mentioned, Runtime 3D application can already run display 3D content on your mobile phone. So the AR capabilities are basically making sure that you can first make everything that you don't care about your scene transparent. So you're only going to render the 3D models that you want to show in your AR application. And the second thing that we need is to make sure that we can synchronize the sensors that are calibrating, that are showing the angles of which your device is oriented. So it's actual location and orientation. And connect that to the runtime camera that actually is used to render from a certain point of view the 3D content. So in this source code, I just basically have a scene where I'm adding just one scene layer, which is San Diego texture buildings. And all I say is, oh, by the way, I'm in AR mode, which means don't try to display anything else but this scene layer of San Diego. By default, we display grids. We display like a space effect, so you see stars if you really zoom out. We have an atmosphere effect. We have a lot of things that we display for normal 3D applications. With just that small API, we just say, yeah, don't do this. I just want my scene layer of San Diego. Then the second thing we need is to make sure that we can control the camera, and the device sensors need to be the one controlling the camera. And to do this, we have a first-person camera controller. And that basically says that, oh, wait, we're going to take the sensor off any phone or anything, and that's what's going to be controlling my runtime camera from now on. To do this, we just use the ARKit motion data source. So I'm using an iOS device. Obviously, it will be an AR core motion data source for Android. And that will automatically connect to the ARKit sensor on your phone and use that to feed the camera position of the runtime. So what does an application like this look like? And if you can switch to number 1. So yeah, it doesn't look great yet, but you get your idea as I can already have a sense of what an AR application could look like. I have the San Diego buildings that are showing up. That's all I have. And I can look at, turn on my device and things and have that experience of moving around my data by actually orienting my device. Obviously, that's not a finished application, but it's just to give you all the bits you need to write your own application. So we actually spent a little time and a little bit more time and build a slightly bigger application with this one. So what you're looking at right now is ARKit giving me all the points that it can actually see in a real world and can be used to render a scene. So I'm setting one of those points, and then I'm downloading an integrated mesh of Yosemite and use it as a tabletop experience. I can make it smaller, maybe orient it to fit exactly where my table is. And I'm always insisting on that, but it's really hard for me to express how natural it is to explore my data in such a scene. I'm the one holding the device, so you don't see the difference of me moving by moving the device around or me moving by touching the screen or using a mouse and everything. But I can tell you this is the most natural way to interact with your data. If I wanted to be on top of Glacier Point looking at the half dome there, it will take me, I will have to scroll the mouse, and I will have to probably pan using a left button. Then I will probably orient using a right button mouse click, and then I will scroll back, and then to be able to be sitting exactly in Glacier Point. When you interact with ARKit motion data source, it's really natural. You can really easy, oh, you want me to be here and look there. Oh, I'm just positioning the phone there, and here I am. So ARKit is obviously made for AR, but you can think about other interactions, other way to explore your data where you don't need to render the real scene behind, but you still want to interact with your data in a very natural way. But so this is still a runtime application, so I can do pretty much what I did in the plenary last year, where I can add an observer, maybe try to add it on top of Half Dome, and see what the view shed from that observer will be. So you see that on that side, he sees a lot on the back of Yosemite. And obviously, he's not going to see much from the phone because he has a Half Dome in front of it. Or I can run, some other analysis like a view shed, for example, by dragging my finger on, and I can render the line of sight from that point, from those two points. So it's just to show you that you still have access to all the runtime API, but you can actually create an AR experience from your runtime application. So I just show you like what we call a tabletop AR, and we already have some team at Esri that are consuming that type, the ArcGIS Runtime beta for AR. One example is that AR story map. So it's just a simple app where I can actually select, for example, a Palm Spring tour, and when I have my phone looking down, it looks like a regular 2D runtime application, except that I'm not rotating the map by using my fingers, but I'm actually rotating the map by turning the phone around. But as soon as I just leave the phone, so once again, I'm not touching the screen, my experience switched to an AR application, and I can actually see every slide that were in that map tour, and see them where they are relative to me in which direction. I can even select them and have more information about, that the pool is right there. I don't know if you know that, guys, but yeah, conference is almost over. And you actually can go there. It's only 105 meters away. And then explore your map tour in an intuitive way. I wanted to mention quickly that the API I just showed you here is the API that we had part of the beta program. And for the past year and a half, we have been going through a lot of difficulties on trying to understand and see how we could expose that publicly. The main issue is that ARKit and ARCore are still evolving APIs. They are changing quite a bit. And they also require a very high level of Android or iOS level. So, and we still need to support all the low-end devices, Android and iOS, for other runtime applications. So as Rex mentioned, we're going to deliver exactly the same functionality, but packaged a little bit differently, where our API is going to expose some of the functionality necessary for an AR application, but the toolkit is what's going to use those APIs and give you the same experience out of the box. The advantage of a toolkit is that you can download the source code. It's totally open source, and you can modify it and do everything you want with it. That's it for code, so back to you, Rex.
Great. Thanks, Adrian. Good stuff. Another thing there, too, to think about is that the dependency on ARKit and ARCore is then tied actually to the toolkit component. So it's not something that everyone has to pay the cost of. It's just if it's something that you need to be able to use. So it gives us the flexibility to be able to deliver something that's responsible, also dynamic. So, and we can update that as well. Now, actually, we just talked about one part of that extended reality spectrum and the experiences across it. With ArcGIS Runtime as it is today, again, we talked about the fact that it's a fairly sophisticated set of native developer SDKs. 3D capabilities are already built in. Data access and analytics are already built in. Being able to take that maybe to the next level and enhance that to be able to provide an augmented reality experience for mobile devices is, of course, what we're targeting with ArcGIS Runtime. But there's also a need here to be able to target the full spectrum of capabilities and to be able to build out those types of solutions. And so being able to target both mobile and premium extended reality experiences oftentimes will require use of game engine. So Eric talked about this before and some of the projects around working with Unreal. What we'd like to do in the context of for developers is provide really a lightweight API that allows access to a limited set of capabilities, really access to data that would be fulfill common use cases in the context of geospatial situations and experiences. And so while game engines actually provide a great developer environment for building out really gaming style 3D applications, the one thing that's driving the integration of geospatial information within a game engine is really extended reality experiences and driving those experiences. And so what we're looking at doing right now, and this is research in progress right now, is building out this lightweight API. We don't need the full sophistication that's in runtime. What we do need at this stage to meet a number of the different requirements that we have or we've seen in a variety of industries is the ability to access online and local data in a format that it was actually published in or it was created in, That includes things like raster tiles for display, like base maps, elevation. Includes things like features, points, lines, and polygons. And when I talk about features, it's not necessarily the symbology, but it might just be the geometry and the attributes, and being able to bring that over so that you can take advantage of the animation, the physics, and the other capabilities that a game engine has. So you might not need the full fidelity of that symbology. You can take advantage of it in a way that the game engine or a game engine may be able to optimize for an experience in that realm. In addition, I3S, so indexed 3D scenes. Layer types, and this includes things like 3D objects like textured buildings, like we saw here, as well as integrated mesh. We also saw that here, point clouds and other cached point, line, and polygon features that are optimized for use in 3D. But being able to consume those directly without having to port them into some other format or to generate some static file, but be able to use them naturally with your current GIS would be ideal. And so being able to integrate within a game engine is really critical to do that. To be able to even participate in these types of situations. And so, granted, game engines have already built a rendering engine that we want to take advantage of. We're not going to rebuild those. We're not going to reinvent the wheel. We just want to integrate within those developer experiences that are available today. And those communities around Unity and Unreal are extensive today, and so we want to be able to kind of graft into that and provide a nice lightweight entry point for developers that want to take advantage of this. One thing that we did, and this was kind of an initial prototype, of course we're doing a lot of work internally that is not currently public, but this is an initial prototype that showed our initial work with HoloLens after it was first released a couple years ago. This is a Unity project where we're taking basically base map tiles from online, elevation tiles from online as well through Global Elevation. We're overlaying those, and we're providing really kind of a cutout, right, of a tabletop experience here for different locations on the surface of the Earth. Note that we can move this around within our surroundings, this experience. We also integrated the ability to work with other operations, and so making a call to our geocode service, and then returning that information in a way that feels like a 3D sort of holographic experience. Of course, in this case, we're working with HoloLens, so you've got the air tap there. So you can see how interaction here has been driven around building out and working with these live services. Note the source code for this is available, so if you happen to want to go out and pull this and take a look at what we've done, what you'll find there is that we've wrapped a lot of REST calls to be able to get these tiles. We've organized those in a way so that you can use these within Unity effectively. You also see that when working with Global Elevation, we're using Lurk encoded tiles. Lurk is a compression format that's actually public as well that we've advertised. So we built that into this solution so we can take advantage of optimized elevation information too. So something you can go out and take a look at, some of our research that we've done here. We'd really like to light this up here, given some additional research and some other productization efforts that are happening as well. And with that, I think we're trailing right into the end. So feel free to please give us some feedback on this in our survey app. And with that, thank you for joining us today. If there's any questions, feel free to mention them. I know we're coming up against the top of the hour. So we've probably got time for maybe a couple minutes of questions. Anyone have any questions they'd like to ask before we close? Yes?
In that Unity example, when you connect up to the Esri data, you can let the Unity convert it into its own mesh definition?
Right, so what's happening there is that we've got imagery, right, and then we're actually bringing that in and using that imagery as a mesh within Unity, right? So just raster imagery at that point, converting that into a mesh that we can take advantage of within Unity. So think of it as we need to get it into a native format that Unity understands. So that's the same thing we need to do in the context of delivering this as a developer product, is that inevitably there's a variety of different formats, and then we do need to bring it into Unity in a format that Unity understands. And so there's a conversion there, but you guys shouldn't have to do that. That's something that should be done via our lightweight API.
And that was my next question, is that you provide that as a C# library that you use within Unity?
Right. Ideally, it'd be delivered as like a plugin, actually, to Unity, right? So some sort of a packaged product that you could download, integrate, add to your project, and then take advantage of through scripting and development. Yep, definitely. It's a good question. Yeah.
So just for the first steps, it's enough to have some, scene in ArcGIS or online or ArcGIS
Enterprise.
Mm-hmm. And the toolkit and the runtime, the runtime license, and the toolkit for augmentation reality.
Right. So if you're looking at supporting augmented reality on a mobile device, so mobile devices, iOS, Android, ARKit, ARCore, What you'd really need there is just make sure that you're working with data formats that the runtime understands. So if you're using part of our platform, like let's say you're publishing scene services, of course we read that directly. We support that today in our 3D capabilities as part of runtime. And then at that point, when you use the beta product, think of it as I want to take my scene, right, which has the ability to render 3D content, but I want to be able to overlay that on top of a camera feed. Right, so we don't necessarily support things like occlusion, so it's not going to be completely immersive, but being able to overlay that on top of a camera feed and have that be synchronized is one of the benefits that you have with the beta that we have right now, and eventually it's something that will roll out as part of the product. Yep.
Because I love the demo with the tabletop. Is it
Tabletop?
So there was just a scene in that application, and it was developed in the runtime with this.
It was, yeah. So the key there, think about the background on the scene, right? You've got atmosphere, you have basically a grid or a surface of the globe. Remove all of that. So basically as part of the AR experience there, all of that is transparent, right? And so the only thing that you're rendering there is layers that are within the scene.
Are there any examples or how to do that,
I think we should, yes, two-step process. The first one is you should try to get familiar with the runtime itself and runtime 3D. So we just actually presented yesterday an introduction to 3D in the
building
runtime,
3D applications.
Building 3D application with the runtime. So you can definitely watch a YouTube video when it's available, hopefully in less than 2 weeks. To get familiar, get your first steps in. Developer.arcgis.com will give you all the information you need. You can even download an application on your phone which has 3D samples, runtime 3D samples. So that gives you familiar with what the runtime can do. And then on the beta website, as I mentioned, with just those extra bits of API, Rex just told you that you can remove the atmosphere, remove the star and everything, and all you see is what you're going to put into your API. So in the sample that is part of the beta, just have the San Diego building, for example. And that's pretty much what you want in a tabletop experience. You just want one type of data showed and everything else is transparent. And then you connect your camera to the AR kit, and then your AR experience is pretty much there.
Yeah, so Adrian actually showed the sample that you'll get when you're in the beta program. Right, so all that's there, yeah.
And one last question. If I want to try to test the VR 360 application, what do I need as an input to the application? Some scene or...
The ArcGIS 360 VR experience?
So we need,
Yeah, so I mean, in order to build an input for ArcGIS 360 VR, you have to use CityEngine as the way to actually create it.
CityEngine is needed?
Yes.
Or the model from CityEngine is needed?
No, just the CityEngine desktop app. You create the item type, share it online, and then you consume it on the mobile app.
Okay, so the scene without the CityEngine model doesn't work here.
Yeah, you can't consume a web scene directly in ArcGIS 360 VR.
Okay, thank you so much.
Right, good stuff. Great, thanks guys. Thanks again for attending. Thanks for sticking around for the last session of the conference here. Hope you guys make it home safely. If you have any other questions, feel free to come up and talk to us. Have a good time, guys. Have a great travels.